Okay, so we have finished the whole chapter 3 already, and there are still 6 MC questions remaining, and let's try it out and see if we know how to do it. So please pause the video and try it yourself now.
A few moments later.
Question 1. Similar to maths or maybe other science subjects, you have to locate the keywords in the question. So the keywords in this question would be same hammer, same amount of force, and which one will have the greatest pressure. Okay, so these are the keywords. I'll recommend you to highlight them when you are doing a certain question. Number 2 usually is you have to recall a certain equation to help. Sometimes maybe more than one. So this time the relevant equation is P equals to F over A that we learned earlier. And according to the question, since you want to have the greatest pressure, so what I would recommend you do is write an upward arrow next to P. And then the question says same force, right? So same force means put across, that means it's not going to change. And you want to find out greatest pressure. And so in this equation, you need to have the smallest area, right? Smallest area. So obviously, it's more about when you are having the pressure on the wood. So on the wood should be the area between the nail and the wood itself. So obviously the answer would be A. And by the way, this is the reason why the nail has to be designed in this kind of shape, because the bottom part, which is going to be hammered into a certain surface like the wood, has to be pointy, so then the area will be small. So even if you try to hammer with a not much force, you can still exert a great pressure. So it's easier to penetrate and get into the material that you want to nail in. And the top here is going to be more flat. Think about this. If you're doing it like B, then you're going to damage your hammer. Probably your hammer will have a dent on on this side, all right, and that's of course not going to be good. And therefore it's usually made to be with a slightly larger area, so it's easier, and also it's not going to damage your hammer. Number 2, it said a man stand on the ground and how it will increase the pressure. So again, it's the same equation, and you want the pressure to be higher. And the thing is, since it's talking about a man, right, the same guy, and therefore the force, which is the weight equals to mg, is going to be a constant. All right, so once again, if you want greater pressure, then area has to be smaller. So it should be not lying down. Bend the knees is not useful. If you are still standing, bend the knee is just like same contact area. Rise is nothing to do with the ground. Raising 1 foot, yeah, that would reduce the area by half, and so increase the pressure by double. So the answer is D. Question 3, which one has the greatest pressure? And these are liquid, so obviously the equation that you need is P equals to rho GH, more precisely delta P and delta H. And so greatest pressure, let's put down an upward arrow next to delta P, and rho are different, so you want rho to be greater, and you also want, well, G you can't change because they are all the same place, right, same planet. So H you also want it to be greater. So let's have a look. X is this density, Y is of that. Okay, then of course X will be better, right, when we look at the equation, and then we have to look at the one with greater height. So yeah, A will be the answer, obviously, comparing with C. Question 4, the description is quite wordy, so if you cannot really understand that, let's look at the most important thing. The most important thing is to find out the greatest water pressure. And so once again, you have to recall delta P equals to rho G delta H. So how you can obtain the greatest pressure. And I suppose this is on the same planet, so G does not matter. So it's more about the density and the delta H. So they allows you to choose depth and temperature. So, well, for sure that depth should be very obvious, that you should choose 20. Okay, so it's either C or D. For temperature, they have already told you that you can choose either 5 degrees or 15 degrees Celsius, but then the density would decrease when temperature increase. So that means if you want the other way around, if you want density increase, then temperature would decrease. So that means a lower temperature. So 5 will be the better choice. So the answer will be C then. Question 5, barometer. So again, you have to recall the relevant equation. And so you should recall that if this is delta H, then it will be related to the atmospheric pressure minus 0, because this is vacuum, right? So yeah, if you don't like to write, that's fine too, because it's an MC. Will equal to rho G delta H. And so in this case, if the atmospheric pressure according to the question increase, so if this increase, G doesn't change, density doesn't change, then delta H would increase. Okay, so that means it will become longer. So the only way that it will become longer is level X will go up and level Y will go down in this case. And in fact, it is very counterintuitive if you pick A and D, because A saying they both go down. Think about this, if they both go down, that means the volume decrease. The whole thing, like some mercury disappear, it doesn't make sense, right? And same for D. D saying that both X and Y go up, right? You can't, this is not possible. You can't have this become higher and this also become higher. Then where does the new mercury come from, right? So A and D are simply ridiculous. So yeah, so the answer is simply C, since you know atmospheric pressure increase. The other way you can also interpret is, since atmospheric pressure increase, so you can imagine there's a greater force pushing on the surface of the liquid on the reservoir, and so pushing this up, and therefore level X will go higher, and of course Y will go lower because it got pushed down. Question 6 is about manometer. I did not create a video on that because it's pretty easy, right? Because the whole idea is similar to the barometer, that you have two levels, right? This level and this level, and the difference, which is 5 cm here, the delta H is again due to the pressure difference. So P1 minus P2 equals to rho G delta H. So yeah, that's basically the same as barometer, and the difference is barometer has the vacuum, which is 0 simply, but this one you will have pressure on two sides. So one probably connected to atmospheric, the other side probably connected to a certain system. So here we have got a container with carbon dioxide, and yeah, this is how it looks like. The most difficult part about manometer is you have to determine which side. You have two sides, right? One is left hand side, one is right hand side. You have to decide which side has a greater pressure or less pressure, because if you just need to calculate for a number, it doesn't really matter, right? You just substitute in the equation and you find it. But the most important and the most tricky part is which side has greater pressure, but then it's still pretty easy to tell, because for the side with greater pressure, think about this, they will push the liquid with greater force, greater pressure, greater force, right? While for the atmosphere here, well, it's also pushing the liquid, but this is like the tug of war, like you learn in chapter 2, right? Depending on which side push with a greater force, greater pressure, and greater force. Of course, the area of these two sides of the tubes are the same, so area doesn't really is a factor anymore because it's the same. And so it's more about the force pushing on each side. And so obviously, if you can push harder, then you can push this lower, okay? And therefore, carbon dioxide must have a greater pressure than the atmospheric. So here, it must not be A, because if it is A, then the level will be the same. And it would not be B as well, because it's more about the difference. not exactly equal to 5. Unless the other side is vacuum, then B will be correct, but yeah, obviously it is not. And for C and D, then obviously we should say above, as we said, this system is having a greater pressure than the atmospheric, so above it, C will be the correct answer.